Okay. So just a reminder what the parent function was and what each of our transformations was. Get rid of all of the numbers and the negatives and all of that and look for the function with the x in it. Your parent function on this first one, we would have called just the absolute value of x. The transformations that we see were an ROX, a vertical stretch by 3, and inside we think opposite, left 1. Did that all come back to us? Okay, it's been a while, right? Same thing here, our parent function would have just been x squared. This one's a little bit trickier as far as the inside outside, but easy to see because this is all in the 1/4 is inside. So inside we think opposite is a horizontal, and this one would again be a stretch by reciprocal. Outside is what we think it is, up 2. And our last one's parent function, again, get rid of all the distraction, all the extra numbers, would have been the square root of x. And your transformations that you're seeing here, we move back to the outside. So vertical shrink by a half. A negative on the inside is an ROY. And then the -2 on the inside, again, think opposite. So that would move us right 2. So hopefully our transformations kind of came back to us a little bit. We are going to see transformations again as we get into our trig graphs, and they are very similar, but some of it is a little more specific to the trig world than just generic transformations. So we'll notice that as well as we go through this. Today, we're going to not get all transformations. We're going to ease our way into it. We're going to first just get to know the graph of sine of x and cosine of x, and then some of the more basic transformations. Tomorrow, we will add in the rest of our transformations. And really what you need to focus on, the better you are at the basic sine and cosine graph and their transformations, then when we move on to the second section of this chapter, which is 4.6, graphing tangent, cotangent, secant, cosecant, it will be so easy, okay? So make sure you really build this good foundation at the beginning of your sine and cosine, and the rest of the chapter becomes like just one little step added on. That's so easy. So we do have a little bit of a build up to talk about where do these graphs come from. And so if you remember connecting our unit circle, if we look at the sine function, in our unit circle, the sine function we know was each of these second values in our graph. Ooh, and that's not a good unit circle to look at because it's missing its pi over 4. Which actually we don't really need because the numbers we're going to see. So our sine numbers were each of these second numbers in our order pair, right? So as we look at this, starting at 0, we had a sine value, and value when we graph means our y's. What is our answer? Our y's. 0, 1/2, square root of 3 over 2, 1, square root of 3 over 2, 1/2, 0. We start repeating these numbers, right? And so then we go into the negative version of those numbers, -1/2, -3/2, -1, -3, square root of 3 over 2, -1/2, back to 0. So if we take each of those, we kind of hit some of the highlights at our axis because those are easy numbers to graph. 0 up to 1, 0 down to -1. And what are those on our unit circle? The angles become our x-axis. So this is an angle of 0, of pi over 2, of pi, of 3 pi over 2, and then 2 pi. And those are the marks you're going to see on there. So what's going to be unique and different to us is now our x-axis will be marked in radians. So what you see here is 4 little tick marks. That's kind of the 4 stopping places around your unit circle. This would be 2 pi, half of that would be pi. That would be our 3 pi over 2 and pi over 2. And the same thing in the negative direction. If I were to make a trip around the unit circle in the negative direction, we'll talk about that just in just a second. But if I put each of these ordered pairs on here at an angle of 0, I have a value of 0 would be this first dot right here. At an angle of pi over 2, if I plug pi over 2 into sine, I get an answer of 1. So at pi over 2, I get an answer of 1. At pi, when I plug pi into our sine function, we get an answer of 0. So I'd be back here. At 3 pi over 2, if I plug 3 pi over 2 into sine, I get an answer of -1. It should be down here. And then if I plug 2 pi into sine, we're back here, we get an answer of 0. And what happens is you would just continue to repeat that all the way. Now, what if I went in the negative direction? So -2 pi, -3 pi over 2, -pi over 2. What if I went negative pi over 2? Remember what that means is I headed down first, right? And if I went negative pi over 2, our sine value is -1. So at negative pi over 2, I'd have an answer of -1. At negative pi, heading the backwards direction here, I'd have an answer of 0. At -3 pi over 2, again, I'm going to go backwards direction here. I'd be up here at our positive y-axis and have a value of 1. And are you noticing a pattern happening here? Okay. And if I go -2 pi, that means I went an entire trip around the circle. In the negative direction, I have an answer of 0. And what happens is we connect this in a nice smooth curve, which then hits all of those other values that we were getting on our unit circle, and it would continue to do what's called oscillate. We'll talk about that word again in a couple weeks. Is it oscillates between those values in this, it's called a sinusoidal curve, and its sine and cosine have that same motion over and over and over because we have the same repetitive values over and over and over on our unit circle. We will not do this connection more than this one time today, is that you're going to get to know these dots right here, and really these 4 dots here are what we focus on, because once we know where those 4 dots fall, I guess 5 dots would really be all 5 of those. That's one complete sine curve. That's one complete trip around the unit circle. And then it just repeats itself. So once we figure out where that goes, we just fill in the pattern around it to fill in the rest of our graph. Okay. So what we are looking at is a sine curve here. We will talk about what's called a period of a sine or a cosine or a tangent, cotangent, whatever. Period refers to how long does it take to complete one full cycle, to hit all of the possible values that you can hit in a sine curve. And like I highlighted on the last page, one complete sine curve starts at what's called your midline, if that makes sense, right through the middle of our picture, right? Hits our maximum, goes back to our midline, hits our minimum, and returns back to our midline. That is what's considered one full cycle or one period of a sine curve. And without a transformation, that length is one trip around your unit circle, or 2 pi. Any questions for me so far? Okay, so we're going to go a little faster through the whole cosine thing. So we're going to look at one trip around the cosine circle, unit circle for cosine. We now know why we are marking this, right? These are kind of the highlighted places around our unit circle. We'll also do in the negative direction here. And cosine being our first value in each of those. Okay, so as we start at an angle of 0, it'd be 0, 1. Your cosine curve actually starts up here at 1. Up at pi over 2, we have a cosine value of 0. So at pi over 2, 0 in our cosine curve. At pi, we're down at -1. And at 3 pi over 2, we're back to 0. And at 2 pi, we'd be back up to 1. What you are looking at there is one cosine curve. Fill in the negative direction. So if I were to go to negative pi over 2, remember that means we headed down first. We'd be down at that negative y-axis and we'd have a value of 0. Negative pi puts us back at pi, the negative x-axis at -1. At negative 3 pi over 2, back up at that positive y-axis with a value of 0. And full circle in the negative direction puts us back here at a value of 1. Do you notice that it does not like duplicate any of these? It goes midline above, midline below, midline above, midline below every time. And if you don't do that, something went wrong. We should follow that pattern every time. And once we get that pattern down, again, these become very easy to draw. okay? So again, what you're looking at is, this is actually two full cosine curves. Your cosine curve starts at a maximum point, hits the midline, hits that minimum point, midline, and ends at a maximum again, would be your standard cosine curve, with the same period length as a sine curve. So what I just highlighted there would be the right-hand side of this, starting at 0, hit the midline, hit your minimum, hit your midline again, hit your maximum, is done in one trip around the unit circle, or 2 pi, again, is the period length for a normal cosine curve. Okay, so talking about transformations then of that standard curve. One of the things that will be impacted is the amplitude of our graph. Amplitude refers to how far above our midline the maximum is, or how far below the midline our minimum is. They will match. Okay, whatever it is always equally spaced along the midline, which is why it's called your midline. An amplitude is a vertical stretch. So if you think back to what we just did on that first page, vertical stretches always appeared as the number multiplying it outside of our function, right? Same for our amplitude. This is a vertical stretch or shrink, the exact same as what we have been used to. Also, reminder that just like our vertical stretches and shrinks, our amplitude is always a positive number. Okay, so we'll always refer to it as a positive number. And then I have up here midline. Now today we're not going to alter our midline, but our midline will always be equally spaced between that maximum and that minimum. Okay. And you always return to your midline between every max or min. So you always have a dot that hits your midline on your way from your max to your min. Questions so far? So changing our amplitude would look like what we used to call a vertical stretch or shrink. Exactly like we would expect our vertical stretch or shrink, but it's easier. We will no longer have to utilize tables and multiply a column of our table ever again, which is why I think graphing these is a little easier. What I do is this becomes the distance from my midline. So as I go to draw a dot off of my midline, I will draw that dot, the distance that is indicated by my amplitude. In the original, our amplitude is 1. So I went a distance of 1 above and then 1 below. If we have a transformation giving us a different number, like this 2 does right here, notice as we leave, so here I'm at my midline, as I leave my midline, I go a distance of 2 away from my midline to match my amplitude. And again, as I identify this, I will always identify it as a positive, because just like we did with our last transformations, a negative will be in ROX. And we would identify it as an ROX. Okay, so amplitude will always be indicated as a positive. It's a distance. Distances are positive. Questions? Okay, and then a reflection. That's another thing we're going to look at today. What happens when we have a reflection? Well, it's going to reflect over your midline. So if I consider again my midline, and our midline is not going to change here today, but in our midline, if I were to take like this point and reflect it, instead of being at +1, it would be down here at -1. This point that's down here at -1 would reflect up to a +1, but all of these points on my midline will not change. And so what you'll notice is it does flip over my midline in my reflection. And I can repeat that in this direction. So this point that is down at -1 becomes up at +1. My point up at +1 reflects down to -1. Connect all those points. My points on my midline don't move. And that would be my reflected graph. In a sine curve, this is still what I would consider my starting point. And I would go from my starting point down 1 when I do an ROX. However you want to mark that for yourself, because we always start on our midline for a sine curve. So to draw an ROX, I would still start on my midline. That will not be impacted by an ROX, but then my first move would be to head down instead of heading up. The ROX reflection for a cosine curve, a little bit different. Again, as we look to reflect each of these points, any point that's up a positive 1 will reflect down to -1. Any point at -1 would reflect up to +1. And all of my points along my midline will not move as you flip them over the x-axis, ROX, and connect. This would be a picture of an ROX. Oops, I can reflect that one too. Finish this out. And so what happens is, typically I would start my graph above the midline. In a cosine's ROX, you will actually start your graph below the midline. So it does impact the very first point you graph when you have an ROX of a cosine curve. It does not impact the first point you graph when you do a sine curve because it's on your midline and those are not impacted by an ROX. What we will not ever see, just to kind of address this one time, is we won't see an ROY. If I were to take this curve and flip it over the y-axis, what happens is I get the exact same thing. So it's kind of not worth our time to talk about those because it's not going to change anything. Okay. All right, vertical shift. A vertical shift is going to move my midline, and here is the numbers can be misleading and the x-axis can be misleading when you have a vertical shift, and so I encourage you always to focus on the midline. If you need to like erase your x-axis, the midline is the x-axis for a lot of our problems until we have a vertical shift, and that will move our midline that distance. And so that's what I would do. Is then everything is centered around this. So if it says cosine +1, that means my midline is the first thing I would move up 1, and then I would space my graph relative to that. So a cosine curve, because we are doing a cosine curve, starts 1 above the midline. Well, if my midline is moved up 1, 1 above that actually goes up to 2. So now my starting point would be here, 1 above my midline. Once I have done that, I now will follow my pattern. I am currently above my midline. So at the next tick mark, I should return to my midline. And then I should go 1 below my midline because my amplitude is 1, which means every time I leave my midline, that's the distance I go. Return to my midline at the next tick mark, and at our last tick mark, return up to a maximum. And we fill in that pattern all the way across. So if I move to the left, I'm currently above. At the next tick mark, I should go to my midline, below my midline, a distance of my amplitude, which is 1, back to my midline, and above. And then once I get those dots in there, I just put a nice curve through all of those. And that would be a cosine curve moved up 1. Questions? All relative to your midline. So once that midline has moved, it is our focus for like how far our amplitude goes, where our amplitude goes, all relative to that. This no longer means anything to us. Okay? Questions? All right. So things we have talked about today. There are going to eventually be letters A, B, C, and D. Today we talked about A and D. A stands for the amplitude, which we previously called a vertical stretch or shrink in trig graphs, specifically called an amplitude. It is our distance above and below our midline. We also learned that it's always a positive number. D is going to be a vertical shift. It's what's added outside of our function, just like a vertical shift would have been previously added outside of our function. If it says plus, we move our midline and entire graph up. If it says minus, we're going to move our midline and entire graph down the indicated distance. And then the last thing we talked about today was our ROX, which would be in front of an amplitude. If there's a negative, and we talked about the slight difference on how we draw that ROX based on whether it's a sine curve or a cosine curve. Sine curve, your starting dot does not change, but our next move would be head down instead of up. A cosine curve, our starting dot does change, and instead of starting above our midline, we would start below our midline. Any questions? Okay, let's try some of these. Eventually, like what we've had so far is all have markings. We are going to get rid of those, and you're going to be given just a line, x-axis and a y-axis. And on those lines, here are the marks I would make. Along my x-axis, I'm going to start with going to the right, making 4 evenly spaced tick marks. My last one today is going to be marked 2 pi. This is always going to be the period, and today we are not impacting that, okay? So that number will always represent the period of the graph. It's the easier way to graph these. We are not changing the period today, so that last tick mark will always be 2 pi. Your requirement is to label the last one and then label half. If you want to do all 4, that's fine. But from here on out, you'll see me label the 4th tick mark and then move back and label the second one as half of that number. Same thing in the negative direction. Negative 2 pi and negative pi. Now, labeling our y-axis, especially today as we are looking at vertical shifts and amplitude, is we want to be a little cautious that we at least label it up enough that we can get all of this in here. So looking at my numbers, what's this 2 going to do to my graph? Down 2 and up 2 away from my amplitude. So I at least need a number up to like 2 and down to negative 2, right? But then the -1 actually centers that down 1. And if I go 2 below that, what number am I going to have to hit down here? -3. So I would number it appropriately to be able to see that. Sometimes you might need to label these like by 2s or 3s or 4s or something if these numbers get big. We can go by 1s here. It's fine, because that'll get us all the way down to -3, which is what we're going to need to see. You would only need to label one of those to indicate what the units are that we're using along there. If you want to label more than one, that's fine. So then my order of drawing this is, if I have a vertical movement, I would draw that first by just drawing my midline, okay? I will say midlines are not a requirement, but people are not very successful with those who choose not to draw, okay? Not a requirement, but I will always draw one. And I'm going to start by drawing it down 1. So you will always see my midline show up on every graph I do. And now everything is relative to that blue line. Everything I do is relative to that blue line. And then we are going to draw a cosine curve, which means my dot starts off of that midline. This distance, right? So starting here, because we are not moving our starting point today, we will start at our y-axis. Cosine normally starts 1 above, but because of my amplitude, I'm actually, every dot I draw will be that distance away, right? So here's my amplitude of 2 away from my midline. Then I start my pattern. I am currently off of my midline, which means at the next tick mark, I must return to my midline. And then I need to alternate. So I was above midline. My next tick mark means below my amplitude of 2, right? Every time I leave the midline, I must go that distance. Return to the midline at the next tick mark and at our last tick mark above. Fill in that pattern the other direction. So return to my midline, 2 below, return to my midline, 2 above, and then connect the dots with a nice smooth curve. Sometimes when our amplitude stretches our graph, it gets kind of hard to not have a smooth curve, like it gets cornery, like pointy. It is supposed to be a nice smooth curve, so try your best. Questions? All right, we're just going to practice a couple here. -1/2 sine x. So start by drawing your 4 tick marks on your x-axis in both directions and getting them labeled out to 2 pi. And again, you can make your graph appropriate to what you are supposed to be graphing as far as vertical shift and amplitude changes. Our amplitude is 1/2, right? So one of the options I could do is label this up to 1 and make that first tick mark indicate 1/2. Or I can label this as 1 and then my dot's only going to go halfway to that line. And that's kind of a personal preference and or how much room you have on that. Let's go ahead and just do this like this and we'll just draw our. The next thing I'll always draw is my midline, which is not moved up or down at all. So I will continue to draw a midline to tell myself that I will center this graph at my x-axis. And then we have to remember where this one starts. We are specifically doing a sine curve this time. So at my y-axis, the sine curve should start. Does the sine curve start on the midline or above? On the midline. Okay, so at our y-axis, our first dot will be on our midline. That comes from the word sine on my midline for my first dot. Then we have to keep two things in mind. Remember that negative means it's an ROX. For a sine curve, that means I should head down first. So my next move should head down instead of above my midline. And my amplitude means that I'm only going to go down 1/2 instead of all the way down to -1. And now we fill in our pattern. Return to the midline at the next tick mark, above 1/2, return to the midline. Fill in the other direction. So this time I would go above, midline, 1/2 below, midline, connect the dots. Questions? All right, I think we have one more example here. Y equals negative cosine x plus 2. Today, nothing changes about our x-axis, so get those 4 tick marks out there. Label out to 2 pi in each direction. And then we slow down a little bit on our labeling of our y-axis. I take into consideration how far above or below we're going to end up. We do have a vertical shift this time, so our midline is going to move up 2. And then I know that my amplitude is 1, so I'll go 1 above and 1 below that each time that I'm graphing. So I would need to get all the way up to 3 at some point here. So I'm going to label up to 3 there. Next thing I'm going to do is graph my midline. My midline should be moved up 2, and now everything is centered at that midline. Everything is relative to that as far as my amplitude, etc. Then this is the one that we tend to have a little bit more trouble with, is our starting point on this one. When I have a negative cosine of x, that's an ROX, and what does that mean about my starting point? Should be below my midline, right? My amplitude's 1, so every time I don't put a dot on my midline, it's only a distance of 1 away from my midline, and that will not change. Always follow your amplitude for that. But because of the ROX, my starting point should be 1 below my midline. At my next tick mark, I should return to my midline. Next tick mark, I should be 1 above my midline. Return to my midline, one below my midline, and now I just keep that pattern going. Return to my midline, one above, return to my midline, one below. All right, what questions do we have? Okay, your check for understanding is your ticket to get your worksheet. You guys have a worksheet today. Go ahead and graph this. You have the option to either graph it on your paper or on your table, but as soon as I see that that looks good, you get your worksheet.